about installing a very important appliance in our home, which is an instant shower head. Now, I have installed a lot of these, and today we are talking about that because in my country, here in Kenya, we use it in the bathroom. Now, we're going to talk about the pros and cons when it comes to these instant shower heads. Many people make a lot of mistakes considering that it is inside a bathroom that generates a lot of steam. Now we are going to talk about the joints. How are you supposed to do that joint? Are you supposed to use an insulating tape? No, 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 no. There are joints that we are going to talk about them here. And that means that today we are touching on how to make a perfect electrical joint. We'll talk about a married joint. How is it? We'll also talk about a T-joint. How do you go about it? And my top boss, I know that today we are going to have a very interactive session. Let me know in the comment section whether in your country you use these, and if not, what do you use, my top boss? So let us get right into it and interact, my top boss, because today we are definitely going to have a fantastic moment, my top boss. My name is John Gatehi, and this is definitely Top Heights Electricals and Electricians. And this very important appliance here is connected using three very important cables. The first one, we have the earth connection. Why did I start with the earth connection? That is a point of safety for the user. Again, this is a device that has to come in contact with water, especially at the heating element, and that predisposes the user to a lot of risk if the installation is poorly done. So today we must tackle that, especially the issue to do with safety. Very, very important, my top boss. Moving on, today is a very special day to us here at Top Heights. Why? We have a top boss that joins us as an intern, and I am very proud of the progress that we have made so far. So my top boss, as usual, in 3, 2, 1, drum rolls, drum rolls. We welcome our top boss here, Simon. Simon,
Yeah,
welcome to our show.
thank you.
Tell us about yourself in brief before we get to instant showerhead.
I'm Simon Kamau,
Mhm.
certified electrical engineer.
Yeah.
Yeah, and today I'm at Top Boss.
Yes, he is a very dedicated, proactive Gen Z, unlike the many Gen Zs that we have out here. How did you find about Top Heights, and how did you get to jump all the loopholes that probably I set, and then today you are here with us?
I've been an active follower in Facebook,
Yes.
TikTok,
Yes.
Instagram. I've been following you up, trying to send some emails, application letters, and unfortunately, I just got an opportunity in your company.
Awesome.
Yeah.
Awesome. What made you to consider Top Heights? We are majorly online, and probably someone would say Top Heights, is just online. Do I really need to look out for them? Why? What made you to, give us a thought?
You as Top Heights Electrical, you are certified by the government of Kenya. Secondly, according to your work,
Yeah.
as we see there at website, online there, TikTok, Facebook, we see you do good work, and I would like working with you.
Awesome, awesome, and you're very much welcome. Simon joins Top Heights Electricals as our intern. We will have him for a period of 3 months or so, and we are going to do a lot of work together. He is bringing his knowledge from school, and we are going to have a fantastic time together. So you will see a lot of videos from him. He's so good when it comes to contactors, motor connections, and I'm so proud. I'm so proud of the progress that we have made as Top Heights Electricals and Electricians, because here we are going to do a lot when it comes to electrical connections. Thank you so much, my top boss. Now, Simon, today we are talking about an instant shower head.
Yes.
An instant shower head is very important in our homes, and we want to talk about the wiring from the consumer unit all the way to this switch and to the instant shower. Do you think it is a very simple installation, and anyone can do it as long as they understand it?
Yes, but it needs some specialized people, because nowadays our electricians are just doing shaggy work according to joints, using wrong cables, selling to you fake shower heads, and that bringing some fault in the house. Yeah.
Incredible, incredible. And I like the fact that you have talked about the cables, and that is very important. The size of the cable matters, because this is a heater.
Yes.
We have a heating element here. The minimum size that we can allow for this, heating element or this device, what do you think about that?
The minimum we can use is 2.5, but the rated wire to be used, it is 4.0 mm. Yeah, because using small wires, and this is a heating element, can cause heating of these conductors, causing some shocks or shorts. Yeah.
Incredible. For me, I would think that a 2.5 mm would actually work, yes, but the problem is the cables will start getting warm.
Yes.
Now, what I have seen also in many cases, you find that once this instant shower head is supposed to be replaced with a bigger one. For instance, this one is rated at 4600 watts, 25 amperes. And in most cases, you'll find that when you use or you select the hot, this is the part that heats water the most.
Yeah.
You find that it switches all the way to 5600 watts. That is a lot of power that is drawn from the circuit. Now, assuming that this is a long circuit, from the consumer unit normally to the switch, and all the way to this is a shower head, you'll find that it is a very long distance, especially in an ideal connection in a house.
Yes.
Now, if you use a 2.5, there will be an issue, because you'll find that that is a very long distance. I don't know whether you remember when we were in high school, we were talking about the resistance of a wire increases with distance, the length especially, as well as the size of the wire. If at all that wire is too small, it means the resistance will be higher. So we need to be very cautious about that. So for me, I would go with 4.0 as the minimum.
Yeah.
And then when it comes to, like, let's say we are talking about the ideal, it has to be, it has to be probably 6. So if at all someone decides to replace this instant shower head with a bigger one, a 6 will accommodate that without the customer having to necessarily change the whole wiring. So if at the point of installation, this is the instant shower head that was in use, if at all the customer decides to, replace with a bigger one, then it will still accommodate without replacing the
cables.
Yeah, now I would want you to talk about this switch. This is a DP switch or a double pole switch.
Yeah.
Some of its features compared to a normal light or a bulb switch. Maybe I don't know whether I can get a one gun switch here. Like we have one. So this one gun switch. No, it is a normal.
It's a normal switch.
This for lights. You can even. In fact, this one is a two-way.
A two-way switch.
Two-way switch.
One gun.
One gun. Yes. So that is the correct way to describe it.
Yeah.
Now, what is the difference between? Can someone use this switch in place of this one for an instant shower head, and why?
No, you can't use a normal switch. According to the current ratings,
Yeah.
of a normal switch and a shower switch, they have difference. When we look at this switch, this is a normal switch, and it entails of a common and L1 and L2.
Yeah.
Because it is a one gang two-way switch.
Yeah.
So the ratings of a lighting switch, it's 15 amperes.
Yeah.
Compared to this one of a shower switch, it is rated 45 amperes. Then on the other side, on a normal switch, we don't insert a neutral.
Yeah.
But in a shower switch, we have a live and a neutral wire connected to the switch, which we, on a shower switch, we have the load side and the supply side.
Yeah.
Yeah, and I will get to show you. Yeah, when we start doing a shower head installation. So what I was trying to say is you can't use a normal switch for shower switch.
Very, very resourceful. Thank you so much, Simon, for that. One thing that is very important that you have mentioned is that a neutral passes through this switch.
Yeah.
So that means that as much as this switch switches the face, it also switches the neutral. We normally say that in the presence of a face, the neutral should never be disconnected. The good thing about this switch is that it disconnects the face as well as the neutral, and that is very, very important when it comes to safety, so that you don't have an issue whereby there is a current flowing or suspended in the instant shower head once this switch is off. All right.
Yeah.
Now, for this instant shower head, what we see here is what is usually common in many homes, whereby you'll find that the cables that have been used, number one, are very long. This is a 2.5 cable. Now, in an ideal situation, if it were top height, what we will do, we will advise the customer, especially if that is their property.
Yeah.
We will replace the entire cables
with a 4.0 mm cable.
Exactly. So running all the way from the consumer unit to this instant shower head, no, from the consumer unit to
the switch.
Yes. And then from the switch all the way here, it has to be 4.0. So I think the best thing that we can do is to start with that, wiring it. And now, if we start from this point, there is another mistake that I would like us to highlight even before we replace it. There are issues here, and probably I'll bring our camera closer so that our top boss Simon can be able to take us through the mistakes here. Simon, if you could please stand at this point so that you can highlight the mistakes that many electricians commit when it comes to the instant shower head.
The first thing is you can see these cables are just naked and wrapped in a metal, which if these cables have a naked point, can make this metal to be
can be in contact with the cable.
Yeah, and it can bring any faulty.
Yes.
Especially if it is alive, it may cause electrocution because the water passes through the pipe and it will be charged. The other thing, it's about the joints. I could like to
get rid of the tape so that you can see.
The other thing is using of tapes. As a stopwatch, you don't use tapes.
And in a short while, we'll be showing people how we do that connection. But we have rightly said that indeed there is a problem when it comes to the size of the cable. So we actually get rid of the entire wiring and then start afresh just to show how good we at Top Heights do it, as you have rightly put it, Simon. So there's a problem there.
There's a problem in these joints. The first thing is that these joints were closed together. Like this. And these are joints. In case of any
like especially in the bathroom, we expect to have steam generated from this device here.
Water.
So once water comes in contact with joints that are too close like this, it means that there is a problem. Would you kindly remove the insulating tapes of individual cables? So my top boss, if you are watching and you're already finding value, kindly smash the like button and share a comment about our top boss, Simon. Simon is very proactive and I like his zeal. He has really looked for me in so many ways. Another important thing is that Simon keeps time. Simon, that is very good of you.
Thank you so much.
Why do you think it is important as an upcoming electrician to be disciplined, especially when it comes to keeping time?
To ensure that you don't quarrel with your clients.
That's nice. Another important thing that I've seen about you, Simon, is that as much as you have been a student and not out here practicing, you have your own tools. Tools are very important. In fact, I discovered that Simon has gone an extra mile and he has this, my top boss. He has his own multimeter, digital multimeter. Why did you decide to have a multimeter? Many electricians who are beginner, they just have a tester and a pliers. Why did you decide to add a multimeter, Simon?
To be accurate in everything I measure. As we know, we use an meter to measure in currents, resistance, continuity. So to be accurate, I use my meter.
Awesome. We have a top boss by the name Adrian here. He has welcomed you. He says, "Welcome, Simon. How are you?"
I'm very fine, Adrian.
Awesome. Now we have our joints here. Most of the showerheads that I encounter, you have those joints. Now, this is absurd. This is very, very bad. In fact, the type of joint that has been done here is very poor, and we don't advocate for these. These are very poorly done joints. Simon, I don't know whether you are set with your pliers. Kindly get rid of one, for instance, so that we can see how bad the situation is.
This type of a joint is a very weak joint.
Wow, you can even do it with your own hands. Without using
a pliers.
much force. This is absurd.
This is what our engineers are doing.
Very, very bad. And even for that one, which is the earth connection. I hope probably it's very hard for you to do with it is not a good joint, that one. And considering this is earth connection, That is a very poor joint.
The other thing
Correct.
I found out with our electricians,
Yes.
is that when doing earthing,
Yes.
you find that they have, okay, after connecting their joints,
Mm-hmm.
they come and put their wires
Mm-hmm.
at this pipe like this.
What? That is the earth connection.
Yeah, at this I think that they are trying to do at the earthing
With the metallic pipe.
with a metallic pipe,
Mm-hmm.
and this may cause faulty. In case
Yes.
of that house having a earthing fault,
Mm-hmm.
this can cause electrical shock even in the taps.
Exactly.
Yeah.
As someone is turning the water on.
Yeah.
Correct. Correct. I agree with you. So instead of that, what should be done in that case? If someone wants to, be extra cautious when it comes to earthing, do you think that earthing should be attached to that metallic pipe?
No.
Mm-hmm.
The other thing is we use our earth faults,
Yeah.
the surge
Mm-hmm.
to produce for us the earth.
Yes.
And the other thing is we introduce something new,
Yes.
which is called an RCCB.
Mm-hmm. Mm-hmm. RCCB.
Yeah.
Most electricians are not familiar with this. They are also not using it. They are also not recommending it for their customers. What is that, our top boss?
This is RCCB.
Mm-hmm.
In full is called a residual current circuit breaker.
Amazing.
Yeah.
Incredible. Yes.
This is used in detecting any earth fault.
Mm-hmm.
In case of any earth fault,
Yes.
it trips.
Nice.
Yeah, and I will recommend our customers
Mm-hmm.
to be using this thing
Correct.
in their consumer units
Yes.
to ensure that even if your shower or cooker sockets
Mm-hmm.
or any applicants have a faulty,
Yes.
this will trip.
Exactly.
Yeah, to ensure everything in your accessories in your house
Mm-hmm.
are very safe
Mm-hmm.
against earth faults.
Mm-hmm.
Yeah.
Absolutely. And I totally agree with on that, Simon. In our consumer unit, if, for instance, what we have here is a surge diverter.
Yeah.
The good thing about surge diverter is that, for instance, here in our country, we have a lot of faults coming all the way from the national grid. And that will definitely strike the customer. That is why in my consumer unit, I have that SPD. Number two, we definitely have this, which we normally refer to as a DPMCB, double pole miniature circuit breaker. And to other people, they can also refer to it as a main switch. The main switch will definitely be referred to as an isolator in other countries. Why? It isolates the entire circuit from the flow of current, so that in case there is an overcurrent, this will definitely trip on its own. But as you have rightly put it, Simon, something that is very important when it comes to the RCCB is that it detects any faults in the circuit. Normally, I say that, not I say, it is the electricity flowing is in form of a loop.
Yeah.
Like you see, if let's say we can have this cable,
Yes.
electricity will flow, in a loop connection. So let's say we have this cable here. Electricity will originate from point A, it will flow all the way, and then get back to point A.
Yeah.
So whatever is in between here is meant to protect us. Now, in this loop, if at all the electricity or the current flowing, let's say it is 20 amperes,
Yes.
it has to go back to the source.
To the source.
Now, the good thing about the RCCB, which you have, if you can show us, it has two main connections. It has the input and the output. But very interestingly, it has the connection for the neutral as well as the line.
The line.
All right?
Yeah.
The neutral and the phase. So that in essence means that it will be connected here. Now, in our loop from the transformer, we usually have this type of connection here. So it will flow through the phase, it will go back through the neutral.
Yeah.
So if we have this RCCB connected in this loop, any current that leaks or escapes from this loop, this RCCB will detect and it will definitely trip. Now, the reason why it detects is if there is any leakage through this important appliance here, that means that it will cause a problem to this device or gadget, or probably someone is receiving an electric shock. The reason why it will trip, shutting down the entire connection or the electrical supply in that home, is to save someone from an electric shock, as well as protect this from further damage. So that is basically the application. So if you are receiving an electric shock, we normally know that that is an easier path. You know, electricity is constantly looking for an easier route to escape. So if you touch it, you become the easier path.
You become the ground.
Exactly. So these RCCB, from this loop, which is supposed to have 20 amperes flowing through it, why is it that there is only 19.5?
And it will actually trip.
Exactly. So if it detects there's something that is coming out of me, why? It will simply trip so that it can save someone from receiving an electric shock. All right. So that is why Simon was advocating for these in every home. You know, so if you're an electrician, advise your customer to have an RCCB. And if you are that customer that you're talking about, ensure that you have this, isn't it? So now, Simon, what do you think? Should we install it? Before we can replace the cable. So assuming that you have gone to a customer who doesn't have it, you'll definitely install it. Now we have made things to be easier. We'll simply connect it here, isn't it? So that means the input is from below here, and then the output is here. So as you get your screwdriver ready, and as you prepare that, I will simply be explaining. Thank you so much for the likes. I see you, top bosses, and I have our own top boss, Eric Musemi, all the way from Kangundo, following us from Kangundo. Eric has been very loyal to our community here as top bosses, and we thank you so much for always interacting with our content, and you being here on our live stream. It means a lot. Top boss, if you are just joining us, smash that like button. Today we are going to learn a lot when it comes to instant shower head installation. So my top boss, let me install this one here. Now what we have here as I header, I don't know whether Simon you can be able to bring our camera closer. What we have here is I tried to, not I tried, indeed I did. I actually prepared this wiring. So what we have here is the provision for our RCCB. There we have it, fitting perfectly. Now for this we will have the, you know, like for this for this SPD, the surge diverter, it only taps from what is coming. There is no incoming and outgoing. We only tap from the face and the neutral, or as other countries will refer to it as the line and the neutral. And then we have the earth connection out here. Now, from there, we will feed our DPMCB from the top, and then at the bottom we have the connection coming out. And what we have here, it is supposed to be a neutral on this line, isn't it, Simon? The neutral is supposed to be fed here. We probably made some errors there. So that is the connection for our neutral. All right. And then we will also have the phase coming all the way from this particular point. So we feed our phase right there from the bottom. So that is the output from our DPMCB. Don't know whether you have the pliers. Thank you so much. So feed it like that. in the DPMCB, it is always good to ensure that your cables are, right angled, properly done, so that it is easier for anyone to interpret that circuit, assuming that you will not be the one to go back there to do, or to conduct repairs. Now, we use to do a lot as Kenyans, ni kama kufanya, assuming that si wewe utaenda kufanya repair. So that is you make sure that it is easier for that electrician who will go back there to carry out that repair work, so that it will be super easier for them to carry that work out. So that is why cable management or cable organization is